Have you ever found yourself gazing up at the night sky, pondering just how vast and unfathomable the universe really is? What if I told you that the universe isn't just an infinite dark canvas punctuated by bright, twinkling stars? What if I told you that it's stretching and expanding right before our eyes? In this video, we'll explore the groundbreaking concept of cosmic expansion, answering the question, how far does the expansion of the universe really go? Strap in, because the journey we're about to embark on will challenge your understanding of reality and might just leave you awestruck. Let's start with a fundamental question. If the universe is expanding, what exactly is it expanding into? You might think this is a simple question, but the answer is far more complex than you might expect. As galaxies drift farther apart from one another, a phenomenon we know as cosmic expansion, it leads us to confront some mind-bending realities about the fabric of our universe. Hold that thought for a moment, because we'll get to it soon. You see, it all began with a Big Bang, a monumental explosion that gave birth to space and time nearly 13.8 billion years ago. Imagine that moment. The universe as we know it was a hot, dense point, and then, in an incomprehensible flash, it expanded. But that's just the beginning. The Big Bang wasn't just an explosion in space, it was an explosion of space itself. The universe has been expanding ever since, and it's accelerating. Yes, you heard it right. The pace at which the universe is growing has increased since its formation. Now, here's a surprising fact: this expansion isn't uniform. Some galaxies are moving away from us faster than others. The farther a galaxy is from us, the faster it seems to be receding. This observation is encapsulated in Hubble's law, named after Edwin Hubble, the astronomer who, in the 1920s, discovered this incredible phenomenon. But wait, what comes next will leave you speechless. Imagine standing on a distant galaxy, looking back at the Milky Way. What you'd see would be vastly different from what we perceive here on Earth. The light from our galaxy would be redshifted, stretched to longer wavelengths. This phenomenon is known as redshift, and it serves as a key indicator of how fast an object is moving away from us. The universe isn't just expanding, it's transforming our reality in ways we've only just begun to understand. You might be wondering how scientists measure these astronomical distances and speeds. One of the ingenious methods is through Type Ia supernovae, which act as cosmic beacons. These explosive events have a consistent peak brightness, making them a reliable point of reference. When astronomers observe these supernovae, they can calculate their distances and velocities, revealing the intricate details of our universe's expansion. Isn't it awe-inspiring to think that we have the tools to decode the mysteries of such vast distances? As we journey deeper into the cosmos, let's talk about dark energy. Here's something you didn't expect. Dark energy makes up about 68% of the universe. Its existence was hypothesized in the late 1990s when observations showed that the rate of expansion of the universe is accelerating, contradicting previous assumptions that gravity was all-powerful and would eventually slow it down. This unknown force is intangible, eluding direct detection, and yet its effects are undeniably felt across cosmic scales. So, what does dark energy mean for the future of the universe? Let's pause for a moment and consider the implications. If the expansion continues to accelerate, eventually, galaxies could drift so far apart that they effectively become isolated from one another, disappearing from our visible sky. Imagine a future where the night sky is stripped of its architectural beauty, where sister galaxies that once danced in cosmic proximity are forever on their own. Certainly a haunting thought, isn't it? Now, let's bring it back down to Earth for a minute. You might ask, where do we fit into this vast cosmos? Our solar system, in the grand tapestry of the universe, seems so minuscule. Yet, we are all part of this grand narrative. The very atoms in our bodies were forged in the hearts of long-extinct stars. We are star-stuffed wondering about the stars, grappling with the monumental questions of existence. But hold on, what's even more mind-blowing is the concept of the observable universe. The observable universe is around 93 billion light-years in diameter. That's staggering. It represents the largest volume of the universe we can see, defined by the cosmic microwave background radiation, the afterglow of the Big Bang. This radiation is like a cosmic map, giving us clues about how the universe formed and evolved. However, beyond this observable limit lies the rest of the universe, which could be unthinkably vast and perhaps even infinite. This leads us to another intriguing question: just how much of the universe can we truly know? Each observation we make brings with it new revelations and often more questions. As we probe deeper with advanced instruments like the Hubble Space Telescope and the upcoming James Webb Space Telescope, we push the boundaries of the known, yet we simultaneously confront the shadows of uncertainty that loom ever larger. When we think about this, it can evoke a sense of humility mixed with wonder. Everything we understand about our cosmos might be a fraction of its totality. The universe, in all its splendor, is a mystery, and every discovery leads us to the edge of new frontiers where knowledge fades into the unknown. Let's take a moment to consider how all these factors, the expansion, dark energy, and the nature of the observable universe, interact. When we look at the sky, we're witnessing not just distant light but a history that transcends time. Each galaxy we observe is a relic of the past, and the light we see today tells us stories that span billions of years. So, how far does this cosmic expansion really go? To answer this, we must delve into the ideas of cosmic inflation, a rapid expansion believed to have occurred just fractions of a second after the Big Bang. Inflation theory suggests that the universe underwent enormous growth, stretching from subatomic scales to nearly astronomical proportions in the blink of an eye. The universe that we see today, those 93 billion light-years of observable universe, is just a tiny fraction of what once was. But here's a twist: while we might think more is better, what if the universe continues to expand infinitely? What if it keeps going forever, stretching beyond our wildest imaginings? The thought of infinity can be unsettling. The very concept of infinity seems to defy our human comprehension. In this endless growth, there would always be new cosmic wonders hiding just beyond our reach. Now, as we continue down this rabbit hole, let's bring in the multiverse theory, a revolutionary concept that suggests our universe may be just one bubble in a vast ocean of universes, each expanding and evolving independently. Could it be that there are countless universes, unseen and untouched, all existing beyond the fringes of our comprehension? Do you see how this notion challenges everything we accept about our reality? In the multiverse, every possibility could exist. There are alternate realities, universes where time runs backward, where physics operates under different laws, where histories diverged at crucial moments. It's a profound idea that expands our understanding of existence itself, pushing the boundaries of not just science, but philosophy and even spirituality. You might be wondering where all this leaves us. It can feel overwhelming, right? This isn't just an intellectual pursuit. It's an invitation to find meaning in our own lives and how we fit into the cosmic grand scheme. Amid this cosmic expansion and its incomprehensible depth, what we are truly seeking is connection. We long for understanding and a sense of purpose in a universe seemingly indifferent to our existence. In this ever-expanding universe, every human story matters, no matter how fleeting. Each moment we share contributes to our collective cosmic narrative. As we chase after the mysteries of the universe, we might find that the journey matters more than the answers. Questions like how far does the expansion of the universe really go might initially seem daunting, but they invite us to engage in the dialogue of existence itself. So, let's get back to the core of our exploration. How far does the expansion of the universe really go? At this moment, we cannot say with absolute certainty. The evidence points toward an ever-expanding cosmos, perpetually unfolding. The observable universe may forever elude our grasp, and if the cosmos holds an infinite expanse, our exploration will be a journey without end. With every answer we uncover, new questions emerge in the vast cosmic playground. Perhaps the expansion of the universe is not just a story of light years and galaxies, but rather a reflection of humanity's insatiable curiosity and unyielding desire to understand our place in the universe. As we wrap up this journey, I encourage you to gaze at the stars tonight. When you do, remember that you are looking into the depths of time and space, into a universe that is still expanding, still evolving. Unlike ancient philosophers who gazed upward without means to interpret what they witnessed, we are equipped with knowledge and technology, tools that allow us to sleuth through the cosmic mystery. So, the question lingers, how far does the expansion of the universe really go? The answer, my friends, is as boundless as your imagination. Perhaps the expansion goes so far that it will forever remain a mystery, enticing new generations of thinkers, dreamers, and explorers to seek answers within the night sky. As we leave you with this thought, remember, the universe is more than just a setting for our existence. It is its own living story, one that continues to unfold with every heartbeat and every thought. Stay curious, keep exploring, and embrace the awe of existence in this magnificent universe.